So we've talked about how we can talk about all circles are essentially similar, right? And so if I have a circle and I have a smaller circle, and I can always remember one circle. So let's say I remember the circle that the radius is 7, then the perimeter is 44. This circle is my friend, in which the radius is 7, then the perimeter is 44. So if I have any other circle, let's say this is 14, the question is, what is its perimeter? Right? So then I can do ratio. I can say, okay, x by 14, I'm going to use the same color for equal to, I'm going to have another color, is the same as x is the perimeter or the circumference, and 44 is also the perimeter. So I say 44, and 14 is the radius. Corresponding to that, the radius is 7, right? And so then the next step is that my x, I multiply both sides by 14. 14 here get cancelled, so I'll have, okay, I can even show that, right? I multiply both sides of the expression by 14. So please make sure children understand that it's not magically transporting to the other side. Sorry, 44 by 7, right? And then this is 2 times. So the result is 88. No? And of course, if the children can say, no, 14 is the double of 7, so then the circumference of this will be the double of that. That's also fine. Very good, right? So like this, you can give a lot of questions. At some point, you can drop the inner circle, and you can simply say, I have a circle which has a radius of 3. What is its perimeter? And then the children will say, okay, this is what is not given. So I know that my x by 3 is the same as Brown is 44 by 7, right? So again, multiplying both sides by 3, x will be equal to 3 times 44 by 7. Sorry, by 7. So 3 4s are 12, and 13, 132 by 7. So another thing that is very useful is to have taught children when you're dividing by 7, if you divide 1 by 7, 2 by 7, what you get, that this whole thing is a repeating pattern, right? So the decimal points, if you get a 1 by 7, will give you a 0.142857, and then it repeats 142857, 142857 repeats, right? And then if you do 2 by 7, then it starts with the 2 and the same numbers, digits will come. 285714. So 0 point, this will repeat, and so on. So if you know this pattern 142857, it repeats. Now of course 22 by 7 is not an accurate representation of what you are looking for, so the children should know that 2 or 3 digits is enough, right? But the idea that I'm dividing by 7 should not be intimidating for children. So for that, if you do all the 1 by 2, 1 by 7, 2 by 7, 3 by 7, all the way up to 6 by 7, knowing that each of them will start at a different digit. For example, if you do 3 by 7, that's 0 point, once the decimal comes 30, right? So 7 4s are 28. So that one will start from here, this 4. So 42857. Then if it is 4 by 7, 4 is 40, so 535. So that one will start with this digit 571428, right? Then if you have 5 by 7, 7 sevens are 49, so it will start with this digit. Right? If you had 6 by 49, it will start with this digit. So every digit, there are 6 digits essentially, and there are 6 possible fractions you can get with 7, right? The remainder can be 0, 1, 2, 3, 4, 5, 6. So leave the 0. From 1 to 6, and this also has the same 6 digits which cycle, which keep repeating.